Welcome to the Migration and Modernization podcast. Whether you've just started your transformation journey or well under your way, our podcast brings expert guidance, customer stories, and practical tips to help you get started or accelerate that journey you're already on. I am privileged to be joined today by Matthew Jorat, Customer Solutions Manager here at AWS. And I'm Ryan Peterson, Worldwide Tech Leader for Modernization. Matthew, I'm really excited that we have the opportunity to sit down today. You know, I came across your blog, and that's actually why we're here today. I asked Matthew if he can come and talk about technical debt, because that's something that really resonates with me personally, but also I'm hearing a lot from our customers. And your blog went through a great practical guide on how to attack that technical debt. I'm wondering if you could start with just a summary of what we'll be talking about today.
Yeah, excited to be here. Thank you for having me, and really looking forward to having this conversation. So the genesis of the blog really came about from me working with a lot of my own personal AWS customers and my own personal journey as an AWS customer in the past. What it comes down to is that technical debt is generally a thing of the past, a relic of the past. It was always defined as a software development problem. And then the cloud, the public cloud came through and it completely changed the definition. And what happened was that everyone shifted their applications from their on-prem to AWS, for instance, thinking that technical debt was a thing of the past, and it turned out that it wasn't. So the blog goes through a pragmatic approach of reducing technical debt in the public cloud while still actually being a viable company and producing new products.
I love the redefinition of technical debt. You know, my background is in application development, so I'll just say I've contributed my fair share to technical debt. But as I knew it from a developer, it goes back to, I think it was coined in 1992 by Ward Cunningham, who was a software developer, right? Yeah. And I like the term debt because it compounds over time, and we call that the interest that you need to pay forward. And from a coding perspective, that was always understood that you're up against really tight deadlines and you just need to ship the software out the door, right? That infamous line of, if it compiles, ship it. And we make a lot of shortcuts and say, we'll get back to that later. And oftentimes that later never comes, and it compounds, and that interest accumulates, and it comes at a cost, right? And your blog, I think, goes into some great detail about what that cost is to the organization.
Yeah, so actually let's talk about that. That perspective is exactly spot on, because the traditional definition of technical debt was all about code, right? Code quality, older generations of programming languages, older generations of or versions of those programming languages. Spaghetti code was a term that was coined.
Yeah.
And inefficient use of code, like the same block of code repeated in different modules for the same application instead of all pointing to the exact same set of common libraries. It was all about that. And it was exceedingly difficult to get through that, because it was a complicated process.
Indeed it was. And I remember from personal experience that we would always ask, you know, the development managers and the product managers, hey, can we just have a little bit of time to clean this up? And of course, other priorities and what's important for the customer seem to always win out. And it manifests itself into longer development cycles. Your mean error rates begin to go up. You start to see these bugs creep within the code. And before long, you're just drowning that technical debt. The other manifestation of technical debt is performance. Your application will start to run slower. And that, I think, is the genesis of a lot of folks that think, hey, once I get into cloud, I have this virtually unlimited compute capacity, and I can simply attempt to scale out of my problems. And that's one way to look at where folks that are coming into the cloud think it's all going to go away. But as we know, that simply just doesn't happen.
You touched on performance, and you know just as well as I do, there are at least a half a dozen other components involved: security, resiliency, elasticity. All kinds of things come into play over time. And exactly as you said, Technical debt accumulates once it starts. It's almost like financial debt. It's really hard to pull yourself from that and actually do something different.
Indeed, it is. And I think that it also highlights some of the different personas that are involved in a lot of ways with migrations and where they begin. And so when they start from infrastructure teams and central IT, it's a very kind of infrastructure forward mentality.
Yes.
Right? And then that's, I think, where the mindset of getting into the cloud will solve all those problems.
So we just talked about the traditional definition of technical debt. And then let's roll the clock back about a decade and a half. The cloud computing concept came into the picture with AWS. And everybody became excited because everybody thought, okay, finally, my technical debt, now I have a way of doing something about it, right? So builders, I was one of them, we were super excited about it because, hey, I don't have to worry about infrastructure. I don't have to order servers. I don't have to go talk to the server people, the database people, the networking people, the storage people. I can just carve out what I need for my specific use case and actually do my work and build an application. That was amazing. That was just so unbelievable at that moment in time, right? And the same thing with respect to kind of licenses in a way, because I can get rid of now some of those perpetual expensive licenses and go with like a managed database. Here's another really important concept, at least for me as a builder, was that I thought, finally, I can get my hands on those really cool, shiny, new techie tools that I can't have right now because I don't have those licenses on-prem. I can get them over there. Right? So from a builder perspective, that was amazing. And then finance people came along and said, great, because that ginormous CapEx, capital expenditure that we have to go through for building data centers, for ordering hardware, for maintaining it, all that goes away. It all becomes OpEx. It all becomes operational expenditure. We pay for what we use. Even if that organization didn't have an on-presence and they were at a co-location facility, they still had to order hardware. They still had to patch their own cables, right? And they also still had to have people on call for somebody to go in and swap a failed hard drive at 2 a.m. There was excitement all around. And so everybody started adopting this concept of lift and shift, taking your existing applications and moving them and shifting them to the cloud. And everybody thought, perfect, we're good.
Yeah, and a lot of times that solution doesn't actually come to fruition, right? And I can relate. I remember here at AWS working with a very large education technology company, and technical debt had accumulated within their core software application to the point that they were down to a single release every 3 months. That was their release velocity. Could you imagine only being able to release new features, bug fixes to your customers every 90 days? And the cost of that accumulated technical debt was a 3-month development cycle, because that's how long it took to actually test and validate and go through. And they said, you know what, AWS, we're moving to the cloud. That's going to solve all the problems. And exactly as you said, they lifted and shifted. Their problems were now just in another place, and the release velocity didn't change. So I think we have a good idea of kind of the problem, technical debt. So how do we tackle it? What do we do? What do we start with to start paying down that interest?
Before I mention that, or before I talk about that, let's also, I want to just play off of what you just said. Lift and shift happened, right? And the panacea didn't happen necessarily, because the concept of architecting in on-prem for a monolith application is fundamentally different from what it looks like in the cloud, right? Think of them as different picture puzzles. You can take the pieces out of here and put them here, and some of them will connect, but at the periphery, there's just no way. Part of that problem was not just because the concept is different, but also the approach is different. For example, the number of times I've seen applications that have these really unbelievable CPU requirements. So they need this much compute on a normal basis. From time to time, they spike this much. Well, I don't know, some event, let's say holiday shopping, right? They shift that to the cloud and they run it at the exact same high CPU. Why? Because when it was in the cloud, it was CapEx. It was sunk cost. So it was no big deal running the app. And quite frankly, some of those apps didn't scale anyway, up and down, so there was no option here. In the cloud, we say you pay for what you use, right? So the application, we want them to scale. But if you can't do it, it's costing you money. That's really not helping to pay down on that technical debt in the way that you thought it was going to happen, lifting and shifting to the cloud.
Yeah, absolutely right. A lot of times the mindset of how you run these applications, how you design these architectures for the folks that are actually doing it doesn't change once they're in AWS. And I think in your blog, you really highlighted that key aspect is that skills gap, right? Where a lot of times organizations don't appropriately invest in their people, in development and upskilling to make sure that they're ready for the cloud, to understand those fundamental differences in how you operate at cloud speed and once you're there, how you take advantage of on-demand hardware, how you can update your applications, shift to more stateless, move to ephemeral servers, and really drive down the overall cost. Because at the end of the day, if you do want to invest and make time for spending on burning down that technical debt, it comes down to cost. And so if there are things that can be done to optimize once you're in the cloud, that's going to then enable that path forward to invest in that burning down.
I love the way you said it. That skill gap is a thing.
Yeah.
And it's a problematic area that we really need to help our customers solve. Here's another perfect example in the context of architecting the cloud way. You see in monolithic applications, the consumers of data a lot of times dip in directly into the database to pull data out, right? In the cloud, we frown on that. Solutions architects have heart attacks when they see that. And the reason is, how do you handle security? How do you handle resiliency? We at least want you to throw like an API in front of it or something. Like that's not a best practice at all. And until that skill gap is narrowed down a little bit, we'll continue to see much more of that going into the future.
And in a lot of ways, get yourself even into more trouble, right? Having that unlimited compute capacity and scaling yourself out of things and getting access to bigger instances can, in a lot of ways, cover up some of those problems when you're not forced to be optimized within the confines of what was already purchased, right? And there was another section that you talk about on how to approach closing that skills gap that I want to dive into, and that is the establishment of a CCoE, a Cloud Center of Excellence. And there's many aspects into it, but helping to enable the organization, helping to drive that upskilling is one thing. But it really also comes down to sponsorship and kind of setting up those standards. Where have you seen success in CCoEs?
CCoE fundamentally is one of the most important components of reducing technical debt. Also, not just that, but your existence in the cloud. So CCoE stands for Cloud Center of Excellence. It is a combination of a cross-platform, multidisciplinary team of folks that assemble together in order to establish certain things, like guidelines for how to establish services in the cloud, guardrails around what you can or cannot do, and architecture best practices in the form of, a lot of times, infrastructure as code in terms of repeatable patterns. The team could be only 2 people or 20 people, depending on the size of the organization, and they are hyper-focused on establishing and enforcing best practices. They're not the office of no. they're enablers. Okay?
Yeah, that's
So
key.
you want all of the developers and all of the builders to stay within the confines of what the organization has deemed appropriate for what they're doing. And so in that process, we say, when it comes to creating a CCoE, start with a centralized perspective, a centralized conglomeration of people. Why? Because all the different specialties that come around that circle of CCoE should all adhere to the exact same methodology. They all have to ensure that everyone agrees what the organization can accept and wants. Over time, though, we want that to be shifted to a much more decentralized perspective and version. And the reason is you want the experts, like database experts, storage people, the networking people, the compute people, to all have sufficient autonomy to continue on their task while at the same time they're adhering to that centralized guideline, sort of North Star of what the organization needs to ensure that everyone is adhering to.
I love the way that you laid it out there, because you hit on one of the anti-patterns that I see in a lot of organizations that go and set up these CCoEs with good intentions, of course, but oftentimes if they are created that are born out of a central IT team that is used to kind of guarding the keys of the kingdom, which is understandable in an on-premises environment because there's finite amount of hardware that needs to be protected. There's security, there's all of these things, right? And so when they get to the cloud and they have that same mindset, and while it's okay to start with that centralization, as you said, you need to move to a decentralized model. You need to move from the centralization to the standardization for this CCoE body. And
that is a good word, by the way. Standardization.
Yeah, that's I think that has helped frame, I think, that mindset that CCoEs need to get to. But in the beginning, of course, everybody's new. And so tying back to the upskilling, what I like to talk to customers about the CCoE is you want to make sure that you're building up capability and clarity of vision for the cloud, and then releasing a little bit of control. Capability and clarity, release of the control. And they have to be in lockstep. Because if you focus on building capability and clarity, but you don't release any of the control, you end up with a lot of frustrated builders, right? And they're going to go on to take those newly acquired skill sets to other organizations that allow them to experiment, that allow them to innovate, right? So you need to release that capability. You need to release that control as you're building up that capability and clarity, as you're upskilling, as they're understanding the way cloud operates. On the flip side, if you release that control too soon, you have chaos.
Yes.
And right? So that's the function of a CCoE, is to really have that end state and goal, decentralize, move to standardize. And I like to introduce kind of the long-term vision of the CCoE. And where I see organizations being the most successful is CCoEs eventually graduating into, if you think about team topologies, into enablement teams, or even sometimes platform teams where the customers are the builders. Again, setting that vision up early, I think really sets the track, as you said, for moving from that centralized to decentralized and having that standard model.
That is a really interesting take on that. It resonates with me tremendously, because one of the things that, for example, the CCoE does is, as we talked about, establishing the guardrails, but in a way to make my life easier as a builder or a developer. So for example, if I'm a developer and I have the idea for some application, there's zero reason for me to have the ability to spin up a 24x EC2 in a non-prod environment, right? There's got to be a guardrail that actually stops me from doing that, even by mistake.
Yes.
Right? And you can flip the script the other way. Even if I'm working in the production environment, if my organization has never touched a Neptune database, which is this sort of relational graph type database, there should be zero way for me to do that without me having a conversation with those folks Like we have to figure out how to prevent mistakes in that way. I should be able to, if I have the idea for a traditional application, a database at the bottom, it's sort of a web server at the top and some code in the middle and some storage, I should be able to sort of check into a library of options, right? Pull some pattern that has already been proven and accepted and throw that in, execute that, get my environment, and now I can hyper concentrate on what I was going to do instead of just worrying about infrastructure and is this database acceptable and those kinds of things. So the way you laid it out was beautiful in that it's enabling me.
I couldn't agree more. And when I work with customers to set up those guardrails, I look to make options so that those are as flexible and soft as possible. And so to your point, not spinning up certain instance classes, some of those are hard limits that are fairly easy, but you also want to allow a certain amount of experimentation and innovation. And so making teams responsible for their own budgets for these accounts and having some alarms and moving from toll booths to those guardrails, having detective controls. And so allowing the freedom to experiment, but at the same time, acting as a kind of a coach in the background, making sure that things are running good. But I feel like we might be getting into more of the platform engineering and developer tool side, and I think that's another episode. So tune in for that one. So going back to technical debt, though, starting with on the way in, right? And so one of the things that I have found when working when working with customers that have been incredibly successful within their industries, that have built applications over years, sometimes decades, is they've accumulated all that technical debt internally within their own network environment. And there's a lot of opportunity to just evaluate what they currently have and look at instead of how to move it to the cloud, but even what not to move, right? And looking at what their core competency is, what's important for their customers. And I really like to introduce the concept that we see a lot in domain-driven design called strategic design, which is taking a look at, what are your core supporting and generic domains. And a lot of times you see companies that have developed something internally that isn't their core competency, but they've done so because simply something didn't exist back at the time. And so really looking at what can we not move to the cloud? What can we instead move to a SaaS provider, for example? Move to a managed service. And that is one of the first steps, I think, of eliminating that technical debt by just eliminating those applications that your organization, it's not part of that core domain. So anything that's in that generic, take a look at moving to managed services. And if you take a look at AWS Marketplace, the number of SaaS solutions that are available out there,
countless,
that you can move more into an OpEx model and not burden resources. I've seen organizations that have written custom email applications. Like that's been solved elsewhere, and you're not an email company, so that's not something that you should spend your time on.
Retire or repurchase some of those in a reasonable way. It's really interesting you say that because at AWS we've published this graph that is called the cloud maturity model. Mm-hmm. On the x-axis, there is migration, modernization, optimization, and innovation. And the graph goes like this, as though as you complete each step, you're a much more sort of modern, mature organization in the cloud. We had the best of intention when we came up with that, right? But it's easy to see how organizations can look at that graph and kind of misinterpret that as each item on the x-axis is its own autonomous individual era of time. Like there's the era of migration, there's the era of modernization, and after you modernize, then there's the era of optimization. And it just doesn't work that way. Success implies in parallel working toward all of those things at the same time. I'll give you a perfect example. We're talking about lift and shift. Mm-hmm. So that's the migration part of it, right? You can also do lift, a little bit of modernization, and shift. For example, if there's an opportunity to containerize an application in the process, you should do that. And the reason is you can really wrap that application in a nice package. And then you don't have to worry about all the different components that it has. And then it's portable. And the same thing with what we talked about, database licenses. You can give those up and go with a managed database in the process, so you can kind of combine all of these things in a reasonable way to truly reduce your technical debt faster over time.
Yeah, I couldn't agree more. And you touched on something that I get asked a lot in my role is, when should we modernize? Should we modernize before we get into the cloud to make sure we're going to take advantage of everything? Should we lift and shift and then modernize? Or should we take a hybrid approach? And a lot of times organizations follow this mindset of we need to modernize first. And studies have shown that that's one of the biggest contributors to failed transformations, right?
Yes.
Likewise, simply lifting and shifting, a lot of time you don't allow for that time to optimize and modernize, and it never happens, and cloud seems expensive, and why did we do this? And even looking at potentially repatriating back into the data center to save on cost. What you said, though, is the right approach. And what I like to advise customers on is how can we look at modernizing what we call the one-step modernization on the way in that's going to create the least amount of risk, require the least amount of resources and time, but yield the highest advantage. Containerization is a perfect example. That's a great way to drastically reduce the operational expense to the organization and free up those resources to be focused on developing solutions and features that delight their customers, or to shift over into paying down more of that technical debt. Another one, move to managed data. Great, another example. If you're not an organization that specializes in database management, then why are you employing a massive amount of DBAs to manage your databases? Moving to managed databases, studies show that you can have each DBA manage over 100% more VMs on the managed data. So remove that. And the other is on cost. And so I think I mentioned this at the beginning, is making sure, this is the one area where tinkering with code I think is okay, moving more into a stateless architecture. So you can take advantage of those ephemeral servers and scale up and scale down. So you're not running at that high watermark because, as you pointed out very astutely in the beginning, that's simply what they're used to. So look for those opportunities on the way in. And when you're designing your migration wave plan, when you go to your second wave, make sure that that first wave has those other modernization opportunities that are key and that are a priority. And one key one that I see that comes very quickly after they migrate in is our move to open source modernization pathway. That is one where you can see an amazing return on investment from an infrastructure perspective. So you mentioned freeing up managing licenses, but actually limiting those licenses altogether, right?
Yes.
So moving from, say, SQL Server to Aurora Postgres, or one of my favorite ones that I love helping customers do is moving to older architecture like .NET Framework into .NET 8 Plus that is available to run
more
on Linux.
Cross-platform ready.
In containers, yeah. And that used to actually be hard to do. And we've been spending the last decade developing tools such as our porting assistant, such as our refactor engine for .NET, right? Making it easier and better. But last year at reInvent, we announced a new service, AWS Transform, which is our first agentic AI migration and modernization tool. But one of the early agents that I love to work with customers on is that .NET modernization. And so it took all of the business logic and the rules engines that we had previously, but added on top of it AI agents that are now able to accelerate the modernization of those .NET applications and move into that license-free environment. And when I first sat down with that tool, the thing that was really struck me, and I realized like this is the answer moving forward. This is what's going to change the conversation of modernization, is to see the reasoning, the power of these LLMs and these agents, that they can go through and follow that more heuristic nature of language modification, but then go ahead and compile, try to run, see the errors, adapt, change, update, and go back and forth and be able to get to that end state in such an accelerated and in such a better way than we ever were before. And so now I'm seeing those conversations that used to kind of end in we don't have the resources or we don't have the time, now able to be revisited. And that's just one example. I'm wondering if you have any others on
interesting
using
you say that
AI.
because AWS Transform, in addition to .NET, can also transform mainframes and VMs.
Yes.
And those are the two big ones also, mainframe especially, because it's such a heavy monolith type of application. Just to be able to pull that and say, this is how you fan it out in a cloud-native environment in AWS, and also give you a wave planning for that, that's gold. Exactly as you said, it's that agentic AI changed the entire picture. And you also interestingly touched on some of those sort of, we have seven modernization pathways.
Mm-hmm.
You touched on some of those. But even if you kind of drop it down one level and look at it very closely, back to the traditional definition of technical debt that we were talking about, if you're looking at it from purely just code, modernization, at some point, you're going to have to deal with code.
Yes.
Right? It's not just, okay, do managed database, there's room for that. Containerize, there's room for that. But at some point in time, you really want to deal with that code, right? So think of, in the past, if you had an application that had 2 million lines of Java 8 code with a half a dozen modules and a bunch of dependencies and 1 million integration points with other applications, that job was impossible to upgrade it to something newer because you needed an army of people to deal with it. You needed developers, you needed security people, you needed technical writers to document it, you needed QA people, you needed DevOps people, and then you needed a bunch of project managers to make sure that they kind of have the touch point with the other applications. It was a near impossible task, right? I don't want to sell services here, but with Amazon Q Developer, you can take the outdated code through natural language processing, basically upgrade most of it. Right? It'll suggest different libraries when necessary. It'll kind of work through the modules. But here's the bonus. All that documentation work that no developer ever wanted to do, ever, it'll take care of it. Right? It'll do the security scan for you. It will create QA test units. And then it'll kind of puts it all together based on what the application is and what the code is. It can even suggest the right sort of EC2 type for you to run that application on. The old problem of I have technical debt, I have really old code, and I can't hire an army of people to help me with it, those days are gone. We can really work through this and accelerate those outcomes in a real business sense these days.
Yeah, you're absolutely right. And I know you say you don't want to sell services, but one of the things that I like about that particular service is it's one of those that came about because we had a need internally.
Yes,
and
that
so
is absolutely true.
The case study of us needing to go through and upgrade all of our Java 8 applications to, at the time it was 17, it was a few years ago, but that supports 21 now. We needed a way to do this, and so we developed this tool internally. And we have the numbers. We saved tens of thousands of hours on these applications through the use of AI to update to Java 17 and now 21, which is supported. But it also attacks another form of technical debt, which is that software composability, because not only does it transform the Java version, but it takes a look at those libraries. As you said, those security scans, those vulnerabilities from open source libraries. So it's doing all of those, and it's doing so in an automated way, which is just fantastic. And so that is a great takeaway from this session, is to look at tools like Q Developer Transformation, to look at tools like AWS Transform on how we can look at automating away a lot of that technical debt that's been accumulated through the use of AI. I want to jump to now another way that we see customers moving away from technical debt through software architecture. And you mentioned AWS Transform for mainframe, kind of one of the last frontiers for modernization, right? That's so difficult because not only are there monoliths, but in a lot of ways, the folks that originally developed those, they're just not around anymore, either because they don't work there anymore or they just have kind of aged out and are no longer with us with the amount of time that some of these things have been developed. And we, with our acquisition of Blue Age, we had the tools that you could kind of do a big bang modernization and end it up in Java with Angular, for example. That was very high risk. And so what I love about Transform is you get to implement one of my favorite patterns in software, which is Strangler Fig, right? You can take a look at your existing code that you don't understand, and AI can go through it and document it, explain what it's doing, explain the business logic, and can understand to the point that it can distinguish which parts of the application are sales and which parts of the applications are fulfillment, and draw what we call those bounded contexts around the applications. And organizations can start to take those out of the mainframe and deploy them and go right to cloud native. This is one of those examples where we're seeing customers leapfrog from the technology perspective and going right into a full microservices environment, running serverless, because they're able to fully understand and use AI to define those boundaries and take them out and deploy to cloud native. So I think that we're on kind of a turning point with mainframe, that we're going to see a lot of customers are going to be able to drastically accelerate that modernization.
If you really pragmatically think about it, modernization in the cloud is somewhat related. If you squint a little bit, is somewhat similar to if you're just already in the cloud and you want to produce a new product, right? Because we want it to be cloud ready, cloud native, and we want it to be based on best practices. So we generally say we want it to be loosely coupled, fine-grained, and event-driven. That's just going to apply to whether you're producing or creating a new application or you're part of the modernization path. Similar thing, same thing. But think of the problem. Even if I'm not dealing with technical debt, even if I just want to create a brand new product, we have developers, they're just focusing on code. And then there's QA that tests the code, right? There's security folks that scan the code, look at it from, best practices perspective. There's DevOps, sometimes DevSecOps kind of combines them, that kind of work through the automation and packaging and sort of path to production, their whole CI/CD pipeline. And then once it's in production, it's the ops teams that takes care of it. Okay. Here's the problem. The developers are not thinking about the maintainability of this app when it's in prod, right? They have zero understanding of what the ops people deal with. The DevOps or DevSecOps people really don't care what language it was written. They're just packaging it up in an automated way and kind of creating a pipeline to production. And then the QA folks, as we've all been through and have seen, we logically think about what this app is doing, but we can't possibly imagine the creative ways the users are going to use that application and break it like the first day. Okay? All these layers were all disconnected and still are disconnected. Again, don't want to sell services, but AWS Kiro is the one that actually makes all of this possible. So you can kind of go from prototype to production, keeping track of all these things and some of the elements that we talked about in Amazon Q Developer, like understanding what the process is, documentation, QA testing, scanning, what sort of services and compute to run it on. All of that is coming together in a real reasonable way. So the future we've been talking about, we're starting kind of to step into it nowadays with all of these agentic tools.
Yeah, and I love Kiro. I've been using it since its release, and I know this is an overused term, but it is truly a game changer. I mean, really orchestrating that from requirements, design, build, test, deploy, and having that all being driven by that agentic AI partner that's right alongside of you it's fantastic. It is the new way of doing things.
We should also talk about optimization.
Absolutely.
Because if we consider the new sort of evolved definition of technical debt is now the entirety of your IT existence, not just code, optimization, cost optimization is a huge part of it. That's another way of in parallel working on all the different components like migration, modernization, optimization, and innovation all at the same time. Because optimization is one that gains immediate benefit. There are tools to look at your compute resources, and we also have AWS Compute Optimizer. These tools do a really good deep dive into all of your resource usage and look at the usage, the pattern, the history, and give you a really good blueprint for like license optimization, right-sizing recommendations, RIs and SPs, combining, for example, on-demand and spot. And right-sizing your compute has immediate benefit. The same with all other kinds of things that are just sitting around collecting dust, like unattached volume, EBS volumes. Right? They're costing you a lot of money. And so the moment we can have somebody say, okay, go look at these things, either attach them to an EC2, or if you don't need them, get rid of them. Or if you're unsure, just snapshot it and throw it in S3 and get rid of the volume. Okay, done. And the same thing with all kinds of backup copies of everything. RDS, for example. There are just backups copies that are sort of outdated, and we need to be able to find a way to life cycle them out of existence. So really consider optimization as a ginormous part of this entire tech debt reduction, because that gives you immediate benefit.
Couldn't agree more. And I want to tie this, I want to go even a little further with this on optimization, because I absolutely believe it's fundamental. And what I see with customers is when they go through those first pass and they just see the amount of waste that exists, because they now have the tools in cloud where they can actually see this. It's amazing how much you can cut down on those first few passes, as you point out perfectly. But it has to be something that is continual and is maintained. Yes. And going back to your description of DevOps, this is where the most successful customers that I've worked with and how they implement proper FinOps is through the appropriate use of cloud architecture. So when you set up your two pizza teams that are responsible for a specific domain, that are developing the applications for the customer, that they're set up in a way that they have their own AWS accounts. They have either a chargeback or charge-through model, and they're responsible for the overall budget. And they create something that we call unit metrics, where rather than its overall cost, how efficiently are you actually running, right? So if you're developing an order fulfillment system, what is the infrastructure cost per order fulfilled? Yeah. And it's the responsibility of the order fulfillment team for that budget. And so having them have ownership and responsibility of that budget drives them into further optimizing that application, driving down that technical debt, because they then have that observability. Yeah. Speaking of
from show back to charge back.
Yeah, absolutely. And speaking of observability and going into technical debt, one of the other things that I've seen with customers that have been successful in not just resolving that technical debt, but keeping it at a manageable level is just bringing observability into technical debt. There's a partner that I want to call out by name that I think has just been really at the forefront of this architectural observability, and that's vFunction. And we work with them a lot. And what they are able to do is develop this dashboard that takes a look through AI again, at the existing applications. Every time code is checked in, tracks the dependency graphs, the cyclomatic complexity of the applications, and can visualize and alert once the applications have drift and have accumulated a certain technical debt. What I've seen is having that visibility into the specific technical debt is a key driver that they can then convince the leadership and convince the organization that they need to spend time on driving that down. So to have these thresholds that are do not exceed, and then go back and they can re-architect and they can actually address that technical debt. So
100% agree.
Yeah, those are some key takeaways that I had. Anything else that you wanted to?
I think we'd be remiss if we didn't talk about EBAs in the context of what we've been talking about. Just perhaps to close all of this out.
Hey,
All
it's
good?
one of my favorite programs.
Okay,
So
perfect.
EBA is our experience-based acceleration program. And we have different what we call parties or flavors that they are. And they actually help along this entire process. So we have migration EBAs that really help developing that skill set and that muscle for moving servers, and not just the technical aspect of it, but how does it impact the organization?
And the repeatable patterns.
Exactly. And then one that's very near and dear to my heart is the modernization EBA, right? And that is key in the driving down of technical debt. How do we look at using our 7 modernization pathways to actually modernize applications and attack technical debt by moving to, say, cloud native architectures, to decompose monoliths into microservices, or architect internally as a modular monolith, right? How do we follow these approaches and build that modernization muscle within the organization? And so what's really different about EBA, though, is it's not just a classroom environment where we're kind of pointing on a board and telling you how to do it. We're actually taking one of your existing workloads, or set of workloads in the case of migration, bringing in either partner experts or AWS experts to work side by side with you as the customer, and developing and upskilling based on your own real world environment, your own real applications. And so the goal is not that modernization of that single application. It's really what the takeaway is, and that knowledge and that upskilling, so that that's something that's repeatable and you can continue to do. I know you've been involved in many of these with
EBA
customers.
ambassador and champion.
Yes.
So
you have some great stories, I'm sure.
I do. I want to just explain the concept a little bit more. Exactly, it's just that we have different flavors of it, different parties of it. But think of EBA as a hands-on, agile, learn by doing methodology.
Exactly,
right?
yeah.
This is a mechanism where we, the collective we, AWS, and our customers come together. We bring all of our experts. We sit next to each other for 2 to 3 days. We roll up our collective sleeves, and we execute on some plan, on some project. And that project has very specific outcomes, goals, and KPIs. We're actually playing to those values. In the process, we ensure that we close the skill gaps when necessary, right? We work through and talk about all the different modernization paths and pathways and everything else that we just talked about. And at the same time, the real magic of the program is that once it's all done, everybody goes home. We don't just close a chapter on it and just celebrate success. We hold ourselves accountable to those KPIs, to those metrics, to those goals, and adjust if necessary. But also, exactly as you said, this is a path to production. We're not just doing a POC here. This is not just a prototyping exercise. This is truly taking something, whether it's a migration or modernization or some innovation project, and actually seeing it all the way to production and to success. And that is the single mechanism in the entire AWS arsenal that actually leads to overwhelming success. Because through this process, we have reduced weeks, probably a lot of times months of work, and we've reduced it into 3 days of actual doing and about a month of prep.
Yeah, I love EBAs. Our customer love EBAs. And what I particularly love about them is, they're usually held over 3 days. And it's always the same comment from customers. Oh my gosh, we got done in 3 days, what normally takes us 6 months. And the big reason is because you have those experts side by side. But also importantly, you have everybody within the customer organization that could be responsible for a blocker to be there and available as well. So blockers are immediately removed from the command center, right? Security issues are immediately addressed because everybody's in the room. And so it really builds that muscle of what it means to operate at cloud speed. And a lot of the modernization EBAs that I've been involved with directly address technical debt in a way that is, it ties back to observability. A lot of times, technical debt, as it accumulates and you're paying this interest, you'll see things like your mean deployment frequency goes down, or the time to deploy from code check-in is extended. And so a lot of those KPIs that you mentioned are For example, that we want to be able to release the application within 5 minutes of code check-in. That demands a lot of automation, drives a lot of driving down of that technical debt. And it's done through that EBA, following those modernization pathways and deploying it using cloud native architecture. And the outcomes speak for themselves. And we have a lot of great customer testimonials that are available on our website. So to our listeners, if that is something that you have interest in, please talk to your account team, because EBAs are truly that transformative.
Absolutely. As customers, talk to your account team. This is the single most amazing mechanism that we have that leads every single time to success.
Fantastic. So Matthew, great discussion on technical safety.
Yeah.
Any last takeaways for
I think maybe just
go?
one last thing. Technical debt is a thing, but the point is not to reduce it down to zero. It's an unrealistic expectation that we've actually heard from some customers. We should just remove that off the table. It's how do you manage it in a reasonable way that is valuable to you and your organization from the lens of at least value realization. So all these other things that we talked about are just to reduce it and control it, not to absolutely remove it, because that is an unrealistic expectation.
Absolutely. So observe, make sure you know what's going on. Make sure you have those thresholds set where you are actually going to force the teams and organizations to drive that down. Look at other kind of contributing metrics. If you're slipping on your mean deployment rate, right? If your mean error rate is beginning to go up, you're starting to see software quality issues. Those are all indicators that you may have accumulated a little bit too much debt, and the interest is costing the organization too much. So establish those practices driven from the CCoE, right?
Yes.
Fantastic.
I've enjoyed our conversation. Thank
Likewise,
you, Ryan.
Matthew.
Really
Thank you so
appreciate
much. Wonderful. And for everybody listening in, if you'd like to share the link for this podcast to your colleagues or anybody else that would love to learn about technical debt, please do so. It's been a pleasure for talking with you today, Matthew.
Same.
I appreciate it. And anybody out there, if you have some comments, questions, or recommendations, please do feel free to reach out either to myself or to Matthew. Thank you so much, everyone.
Thanks, everyone.